Greetings, I'm Professor Hobo, and welcome to another HOBOTECH News product review. Back in the year of hell 2020, I previewed the prototype version of the LEOCH 2 kilowatt UPS solar generator to much fanfare. It was serious bang for the buck, but it still had some issues that need to be worked out. Fast forward nearly 6 months later, and the professor finally has in hand the retail production version to see, is this the hottest deal in 2021? Or is it just a goofy looking paperweight on wheels? Let's find out. The LEOCH sports a 2048 watt-hour lithium iron phosphate battery rated at 3,000 cycles, or 10 years of normal use. As for size and weight, the production model is significantly smaller than the prototype and has actually dropped about 2 pounds. 20 inches by 14 by 10, maybe 11 if you're counting the sides. You know, these sides aren't flat, they kind of stick out. The LEOCH is all ABS plastic all the way around. It does sport these wheels in the back to help you pull it from the handle up front. It does have a bin in the top where you can actually store the cables, which is different than the prototype. Now, the thickness of the plastic is certainly better than the prototype, but in my mind, it's something that's still a little bit thin and flimsy for something that weighs almost 70 pounds. And as for the display, it's unchanged from the prototype. It still shows the basic 5-segment battery icon that shows the battery charge level, and it does show you input and output watts. As for the inverter size, it is a pure sine rated at 2,000 watts with a 4,000 watt peak, and it does have 4 15 amp outlets. Now, this shares the 2,000 watt inverter. As for ways to charge, the retail version LEOCH is different from the prototype in the fact that it now has 3 inputs on the back instead of just 2. For AC charging, plugging the LEOCH directly into the wall with the included cable will net you about 280 watts of charging, which means you can top this up from 0 to full in about 7 to 8 hours. And if you choose the perk that includes the second AC wall charger, you can bump that charging up to 560 watts or down to 3.5 hours, because this does support simultaneous charging from all 3 ports in the back. So you plug it into the wall, gives you your first 300 watts, you plug this in to the middle port, and that gives you another 300 watts. And if that's still not fast enough for you, you can add your own third-party charger into the Anderson solar input on this and pump an additional 300 watts into it, good for charging the LEOCH in under 2.5 hours flat. That's some of the fastest charging on the market. However, it does require 3 sources of charging. As for solar charging, the base model does include an Anderson input, which has its own MPPT solar controller in it, good for up to 300 watts of solar charging. It does come with this cable, allows you to hook any kind of third-party panel in using the Anderson adapter into the LEOCH. Now, the LEOCH's a little different from other solar generators in the fact that it doesn't support putting panels in series. It only supports putting panels in parallel. This Anderson input is actually good for 35.5 volts up to 20 amps. So this is a high amp input compared to a lot of other solar generators. Now, to make your life easy, LEOCH does include these parallel adapters with the product that allows you to hook up to 3 solar panels in parallel. And if you opt for the upgraded solar perk, it actually includes a second third-party MPPT controller that you can plug into the center input here and add up to 300 watts more solar. So in total, the LEOCH with this perk actually supports 600 watts of solar charging. Now, we'll go into this more later, but with the base model, you can charge from solar in under 7 hours, and with the added MPPT controller, you can bring that down to 4-hour charge time. Now, that's going to be under ideal conditions. The LEOCH can also be charged from an external lead acid or lithium battery with the included battery clamp cables, and you can also charge from a 12 or 24 volt vehicle with the included car charger, which is good for up to 150 watts. So from 12 volts, you can expect to charge the LEOCH from day in about 18 to 20 hours, and at 24 volts, cuts that back to about 14 hours. As for 12 volt outputs, the LEOCH does offer a single regulated cigarette lighter style socket rated at 8 amps and a pair of 55-25 ports, that's 5.5 millimeter by 2.5 millimeter, rated at 3 amps. These are all regulated at 13.3 volts. As for USB output types, there are 6 outputs total. 2 of these are 60 watt power delivery ports, 2 are 18 watt quick charge ports, and 2 are the typical old-fashioned dinosaur-like USB-A ports. As for other features, the LEOCH does come standard with this blingy blue light show, if you're into that kind of thing. It does also have a true UPS relay built inside. As I mentioned before, these do have wheels on the back to help you pull it, but this works best if you regress back a few million years into an Australopithecus. Seriously, don't do this if you have a bad back. I'm still hurting. As for the warranty, the LEOCH does offer a 2-year manufacturer's warranty, and they do have UL certification on this product. And of course, we took the LEOCH into my secret laboratory where we performed all kinds of crazy experiments on it. Since we didn't do an AC capacity test last time, we did one this time. Results of the new and improved LEOCH 1,840 watt hours. The results of the AC capacity test, which tests how much battery can you get out of the AC outlets, the results were 1,840 watt hours out of 2,048, or a very respectable 90% efficiency. Now, I didn't repeat the DC test because I did this previously with the prototype and the battery, and that 12-volt circuitry hasn't changed. Those results were 2,077 watt hours out of 2048. You're probably wondering, how the heck can you get 2,077 watt hours out of 2,048? That's impossible. Well, here's the thing. LEOCH actually underrates the battery size. They claim the battery inside of this is 92 amp hours at 24 volts, or if you convert that to 12 volts, that's 184 amp hours. And that comes out to about 2,200 watt hours. So they advertise this as a 2,000 watt hour power station, when in fact, it has 2,200 watt hours inside of it. Now, this is a smart thing to do because it gives you a more accurate representation of what you can actually expect to get out of this product. Now, if we take the true battery capacity of 2,200 watt hours into account, the test results come out to a more realistic 84% efficiency for AC inverter use and 94% for the regulated 12-volt output. Note that the 12-volt output on this is only rated at 8 amps, which is much lower than most other solar generators, and probably one of the reasons why it's so efficient on 12 volts. Since the circuitry for the 12 volt is so low, it's much more efficient than a lot of other solar generators. Now, this is good news for those of you who plan to run 12 volt refrigerators on this, because that means it's going to run a lot longer than, say, on a BLUETTI AC200 or even a JACKERY, because those have a lot more overhead on their DC circuits. Now, we did a DC output rate check. We can pull up to 9 amps from the 12-volt socket and up to 3 amps from the 5525 outputs. So you get slightly more power than what it's rated for, but it's still nowhere near the 10 amps you get pretty much with everybody else. Now, this isn't going to be a problem for most of you because most of you are going to use this 12-volt socket for stuff that's under 100 watts anyway. Now, as for the inverter test, we had some mixed results. Let's check those out. Sine wave check. It looks like we're getting a nice clean sine wave at idle at 118.7 volts, 60 hertz. Now let's see what happens when we add a dirty load.
Giggity, giggity.
Still 117 volts at 60 hertz, no change in the sine wave. And that's at 1,300 watt load, so pretty impressive there, LEOCH. Okay, what we're gonna do next is max out the inverter. I have the heater running on the floor. It's pulling almost 1,300 watts. And we're going to add solar degenerator to that to get this to 2,000 watts. So let's see what happens. All right, adding power. As I add solar degenerator with the heater on, we completely lose that sine wave and we lose the voltage. I wonder what's going on there. So it doesn't like resistive heating that much. Well, that seems to work. Overload. Okay, so the LEOCH inverter did not like the solar degenerator combined with the hairdryer. It didn't like the solar degenerator combined with the electric heater. So we're going to go ahead and do a hairdryer, which is not a variable resistance load. So this has a variable controller on it, which that might be causing a problem because it's a kind of a variable resistor in there. That might not be a good combo with other heating elements. So we got the heater on the floor going at maximum, 1,250 watts. I'm gonna add a hairdryer to it. Let's see what we get. And I'm watching over here the sine wave and the voltage as well to see what happens. 2,050 watts. Oh, it overloaded. But it was 117 volts with a pure sine wave. Okay, sine wave still looks good at 1,600 watts. Let's add some heat. Now we're close to 2,000. We're down to 114 volts. That's totally acceptable. 60 hertz. Sine wave still looks good. Let's go ahead and run it at where I know it'll run. Let's see if we can get at least 5 minutes out of it and what kind of noise we get out of the inverter. Stopwatch enabled. Loads enabled. So we're going to run about 1,950 watts and see how long we can go. I'm getting some fluctuation. Uh-oh. What the hell? That was weird. There it goes again. The hairdryer just shuts off. Oh, we seem to have an issue. Watch this, folks. We're at 1,900 watts. Look at that. The voltage drops to 75. What the heck's going on? So that was strange. We got some really odd behavior from the LEOCH inverter when we were running it at around 1,900, 1,950 watts for several minutes. I don't know if it's a heating problem or what. The air coming out the back was pretty warm. One thing to note is that the fans are running on this, even though I was running an AC load on it. I could barely hear it. Let's see what kind of decibels we're getting. Under 45 decibels. So there are the results of the inverter test. Kind of strange. Now I did run this big heater that I have for probably 15-20 minutes to discharge this a little bit to do some other tests. It had no problem running the heater by itself. Whenever I added anything else to that, including the solar degenerator heat gun or that hair dryer, it started to quag out a little bit. It didn't really handle the heavy loads. It seems fine at 1,700 watts. When I was pushing it to 1,950, you guys heard the hair dryer basically conk out, and then the voltage dropped on the inverter to 75 volts, which is insane. So I don't know if it's because this thing was getting hot and it was like thinking about shutting down, but quite didn't. I didn't smell anything coming out. I didn't smell anything burning, although this was putting out 112 degree heat, which is kind of warm coming out of an inverter. Regardless, I still think the inverter in this is pretty good. It has a really strong sine wave. It holds the voltage very well, as long as you don't push it too hard. Once you start getting above 1,800, it starts acting funny. So keep it under 1,800. I would say 1,600, 1,800 is probably the most you ever want to push out of this inverter. So take that with a grain of salt. I don't think that the minor issues I've seen here with the solar degenerator and a heater means this is a no-buy or a bad inverter. By no means. It seems to self-protect just fine, but that is a weird situation when it gets up close to 2,000 watts where it cuts the voltage and does weird things like that. So I stress that if you own a LEOCH or if you plan on buying a LEOCH, that you keep those inverter loads under 1,800 watts where the voltage is still stable. If you exceed 1,800 watts and it drops voltage really hard like that, there are some appliances that could get damaged. All right, max charge rate test. We're now using my variable voltage charger to pump power into the LEOCH. Now last time I did this, I blew up the solar controller in the LEOCH and it became completely useless. This time I'm not going to exceed 300 watts. I know I typically do push them to their limit, but I know how sensitive the input is on this. And they got warnings all over the back of this that say, do not exceed 300 watts, do not exceed 35.5 volts. So we're not gonna do it this time because I don't wanna burn this thing up. And there goes the dim screen. So I was telling you before, the screen will dim if you wait long enough. So 12.6 volts, we're getting 113 watts, totally expected. Let's go ahead and bump this up to 13.6, a running vehicle, and we're up to 124 watts. So let's take it to low and solar panel voltage, 18 volts. Well, we're up to 176 watts now. So the MPPT is not only kicking in, it's doing it very quickly. You can see as I adjust the voltage, this thing just immediately climbs up on the wattage. So upper end, single solar panel, 24 volts. We're now up to 232 watts. Now we know this thing can take 300 watts to 35.5 volts. So let's go ahead and do 35 volts. Okay, we're at 35.5 volts. It's actually 345 watts. That's kind of bothering me. There we go. That's maybe a little safer. So while it does say that the cap is 300 watts, it's pretty easy to exceed that if you're above 30 volts. So just remember, don't put more than one solar panel on this unless you're doing it in parallel. So unlike a lot of other solar generators where they want you to put the panels in series, the LEOCH wants you to put the panels in parallel. In fact, they give you these to tell you, put them in parallel, because if you put two panels in series on this, you're gonna burn up the solar controller. So don't do it. Put them in parallel. You don't want to exceed that 35 volts because like I showed you in the prototype video, I smoked it in under a minute. So I'm not gonna do it with this one. Do note that the LEOCH does have 3 inputs on it now. The prototype only had 2 inputs. They do have this new connector on it, which is basically an XLR connector, and you can pump 300 watts into this. This connection does not have any kind of solar controller or anything built into it. This input here is the same input that came on the prototype that has the pretty much useless circuit breaker, which did nothing for me, preventing from blowing up the prototype, but it's there. It does say solar input 10 to 35.5 volts, 300 watts maximum. So this is an Anderson connector. So you would typically run your solar panels into this. Now, if you do want to run more than 300 watts of solar panels, you have to run this other connector. And in that case, things get a lot more complicated. Now, you have a couple of options depending on which perks you got on the campaign. This is the extra charger that you can get as part of a perk. This has the XLR connector on it, so you would just plug this in, then you can plug this into the wall. You can do this at the same time you have it plugged into the wall here, so you can actually do double AC charging on it. Let's see how fast that is. Okay, first let's plug it directly into the wall and see what kind of charging we get. Okay, we're getting 284 watts. So now let's go ahead and plug this in. Now we've bumped up charging to 524 watts. So you can significantly speed up the AC wall charging on this just by plugging in that additional AC wall charger. But what else can you do with that input? Well, you can actually put solar into it as well. It's just kind of complicated. So if you opted for the perk to allow additional 300 watts of solar charging, they didn't put it inside. They give you this cheap 10 amp MPPT controller that you have to hook up yourself. Let me show you. For those of you who are not comfortable with wires, electrical, hooking up solar and all that, you're not going to want to do this. Okay, I'm going to tell you right now, you're not going to do this. Comes with this MPPT controller. This is something you'd mount on the wall, right? I don't know, maybe you can just screw it to the side. I'm sorry, this is the most ridiculous thing I've ever seen when it comes to solar charging with a solar generator. They put one controller inside. Why didn't they just put a bigger controller in it? Get rid of this crap. Put a larger controller in it that allows 600 watts. Why do this funky multiple input solar control, external solar controller thing? Anyway, so it looks like they went down to the local hardware store. They picked this up off the shelf probably. They have this really cheap cable. This isn't even solar cable. This is like something made out of a extension cord, like a 99-cent extension cord you get at Walmart. Then they put the XLR connector on the end, and you plug that in, and because it's plugged in directly to the battery, this turns on because it's getting powered by the LEOCH through that port. So how do you hook up solar to this? Well, I hope you're good with stripping cables and stuff, because you have to actually strip your own cables and put them into these inputs. They don't provide anything for you to do this. So they give you this, which plugs into the LEOCH. But now you have to wire your solar panels into these little tiny connectors. So basically what you can do is you can find an adapter online that's a pigtail, basically MC4 connectors like this, and on the other side just be bare wires. This has an Anderson on it, but let's pretend it's bare wires. Then you can put those bare wires into here. Make sure you don't get them wrong, because there was a positive and a negative. You don't want to get those backwards or it won't work. Could potentially fry this. I find that completely unacceptable, absolutely ridiculous. I think this is the worst solution they could have ever come up with, and it's definitely my biggest gripe. I decided to go ahead and bow to the absurd and hook up my variable voltage power supply to the MPPT external controller that they give you. And I found out something very interesting right away. Because this is a 24 volt battery, you can't charge it with less than 24 volts. So that means you have to have at least 2 solar panels in series on this MPPT controller in order for it to work. Right now, I am pumping 28 volts into this controller. Now it's powered up and it shows that solar, because this is a fake solar array, that solar is coming in. It shows a little arrow showing that it's charging the battery. But you come over here on the LEOCH shows 0. It's not charging at all. Now I have to bump up the voltage above 28 volts in order for this to start charging. So let's bump it up to 30. Oh, you see the lights kicked on. Did you see the little bling stars? The little bling lights come on, telling you that it's charging. So now at 30 volts, it's bringing in approximately, looks like about 190. It's going up and down. It can't make up its mind. 30.5. It settles down to 270 watts. So right away, it just goes ahead and just takes all the power that this thing can give it. So you have to run 2 solar panels in series if you're going to use this external MPPT controller that they give you. Now, this can handle up to 60 volts. So that means you can put 2 pretty big panels in series. Like you could put a couple of, probably 200 watt, 250 watt solar panels in series. As long as you don't exceed the 60 volts on this controller, you should be all right. So let's just go ahead and give it everything we got. Interestingly, nothing is happening. Why is it not working? It's still showing PV going in. Well, this is very interesting. It's not charging now. Let's go ahead and shut her down. Let's bump it back up again. No, the LEOCH is just not charging. Oh, there it goes. Okay, let's try that again. I want to crank it up. I want to crank it up all the way. Let's take it up to 51 volts. This can output, I believe, 10 amps, but this can do 500 watts. So basically, I'm feeding the LEOCH 500 watts right now. We'll see how much it's actually taking. So it's taking 260 watts out of the 500 that this can provide through the MPPT controller. So lesson learned here is you actually do lose power with this box, because I'm feeding it 500 watts. This box is consuming some of that in order to convert it to the proper voltage to give to the LEOCH. The LEOCH's only charging at 265 watts. When you saw the previous test where I was using the actual built-in controller, we're able to exceed 300 watts no problem. So that tells you that there's an inherent inefficiency with this controller. This is not a good controller. It's a cheap 10 amp MPPT. I'm surprised they even provided something like this with this product. It's kind of a disgrace, to be honest. Now, there's one other thing I noticed about this wonky solution. I am basically changing the voltage coming into this MPPT controller. I'm going from basically all the way down to all the way up, and I'm fluctuating it like there'd be clouds coming by. So when a cloud comes by, it goes over your panels, panel voltage drops. And that could, sometimes that confuses MPPT controllers, bad ones. So what I was sitting here doing is I'm just fiddling around off camera, adjusting the voltage up and down. I noticed this thing doesn't charge all the time. So right now, I'm going to turn the voltage all the way down. Let's assume that the solar panels got disconnected. Now we're going to go ahead and turn them back up. We know we need at least 30 volts. Well, now nothing's happening, right? I don't know why. 33 volts. Okay, now finally it's kicking back in. We're at our maximum 270 watts. It doesn't matter what voltage you put in, 270 watts seems to be the maximum through this controller. Okay, let's go ahead and crank it up because, hey, the sun's out, there's no clouds, let's crank up the voltage all the way. The MPPT controller freaks out, and now we're not charging again. So I'm pumping 500 watts into this MPPT. It's coming into the LEOCH, but nothing's happening. It's not charging. Now I can turn the voltage back down again. It's still not charging. I'm turning it all the way down to 32, 30. It's still not charging. Okay, I have to turn it all the way back down, and then I can turn it up again. It's still not charging. These connections are good. Oh, there it goes. It just took a few seconds there, but it did actually decide to go ahead and charge again. Let's go ahead and crank up the voltage and see if it stops. There it goes again. I only put 40 volts in and it stops charging. This solution doesn't work. My suggestion to anybody who still hasn't bought this, who's planning on buying it now, don't bother with this perk, okay? Just get the LEOCH, charge it with the 300 watt solar, and just consider that good, because this solution, I can tell by testing on the bench, this isn't going to work in real life, because the voltage goes up and down when there's cloud cover. Big cloud comes over your panels, the voltage drops, and then when the clouds go by, the sun comes back out, the voltage goes up. This should detect that and correct. It is not. The LEOCH doesn't have a problem. It's this little box that has the problem. So I'd suggest getting your own good quality MPPT controller to hook up to this if you really need to have that second set of solar inputs. As you can see from the results of the max charge rate test, we do have some mixed results again. The AC input and the built-in MPPT controller work flawlessly, but the add-on MPPT is really sketchy. When it works, it provides up to 260 watts of extra solar power. However, I had issues getting that to work consistently. As for other findings, if you want to turn off the blingy light show, you just double tap the power button and the light show will stop. And previously, when you turned on the LEOCH, there was an insanely loud beep that would wake up the dead. Now, it's more of a little chirp every time you turn it off and turn it on, you get the chirp. Now, this has been toned down significantly from the prototype, but I still don't understand why you have to have a beep of any kind every time you turn on and off the product. Now, let's go ahead and demo the feature that most of you are buying this for, and that is the UPS or uninterruptible power supply feature. Now, on the back, you have a regular AC plug that you would see like on the back of a computer monitor, something like that. Uses a standard cable you can get anywhere. So we go ahead and plug that in, and this is a 15 amp connection, so you can push up to 15 amps through this cable. And now on the back side, I'm hooking up my kilowatt meter, which is going to tell us how much power is actually coming through this cable going into the LEOCH. And you can see here we're charging from the wall outlet at 286 watts, so that's typical. So if you turn the inverter on now, you have a UPS, which means you can plug something into this and it will power it as long as there's power in the battery. So I have this 1600 watt heater. Okay, you can see the light is on the heater, and it's now pumping out a lot of power, but nothing's showing up on the screen. That's weird, isn't it? Well, no, because it's passing power from the wall outlet into the LEOCH, bypassing the batteries completely and powering the outlets down here. So the battery's not being used at all. In fact, the battery is still charging at 286 watts. So this will charge while it's passing through power directly from the wall. So over here we have just over 1600 watts going in. But what happens when you actually cut the power? So let's pretend nearby lightning strike, power outage. You heard a click, and then the LEOCH instantly takes over within 20 milliseconds, switches from external power to internal power. So it's a pretty fast switchover. I don't think it would affect computers or anything like that. 20 milliseconds is fairly fast, unless you're running some really, really sensitive computer. So now you see we're pulling 1250 watts. So the LEOCH is now powering the load while the power is out. So power's out, nothing changes for you because the load's still powered. So you can still be on your computer, still watch TV, power air conditioner, power heater, whatever you're doing. Okay, so now the power comes back on. You hear the click, you see all the numbers change, and now it's passing power back through the LEOCH again and not using the battery. In fact, the battery is now recharging. So you can see how this works as a UPS. So it doesn't matter if the power's on or off, it still continues to power the loads as long as you have the inverter on. So what do I like about the LEOCH? Well, besides the high cycle life lithium iron phosphate batteries, which is now becoming a lot more commonplace in the solar generator industry, it definitely has to be that built-in true UPS relay. That's got to be the main cool feature here. And the next coolest feature has to be the three-way charging, where you can actually charge this from 3 different sources at the same time to get this thing to charge very quickly. So what don't I like about the LEOCH? Well, the absolutely worst feature by far has to be the ridiculous external MPPT controller workaround thing they got going on here. It makes absolutely no sense, and it doesn't even work right. The first cloud that passes overhead or shadow by your cat just completely kills the input. This is utter trash. What LEOCH should have done was just upgrade the MPPT controller inside of this from 300 watts to 600 watts and been done with it. I'm sure they decided against that because they wanted to shave a few bucks off the price. And that brings us to the best part about the LEOCH, its current price. When I reviewed the prototype last year, they were crowdfunding for $9.99. Amazingly, they're still selling these through the Indiegogo in-demand storefront for only $10.49. Now, before you all tune out and go running away because I said Indiegogo, I want you to all know the crowdfunding bit has been long over. They succeeded in the campaign and they got fully funded. In fact, LEOCH is now shipping these exact same retail version out to customers right now. Many of you have been chiming in at my Facebook group, the HOBOTECH crew, and talking about your LEOCH and sharing photos. So if you already got your LEOCH, feel free to come on over to the Facebook group and post a photo and talk about it. So what's the competition? At this price point and feature set, there really isn't much competition. To be honest, I'm not even sure how LEOCH is even making a profit here. The BLUETTI AC200P is likely the main competitor as it offers many of the same features except it doesn't have a built-in UPS, and it runs about 600 bucks more. Although the BLUETTI does have much better dual charging ability, fantastic MPPT, rock solid true 2000 watt inverter. It also offers better power delivery charging and wireless charging along with a fancy touchscreen and a 25 amp DC output. But as the saying goes, you get what you pay for, and that's the case here. That being said, the LEOCH can't be beat with a stick if you just want a basic lithium iron phosphate SOGEN with basic charging, a basic inverter, with basic 12 volt and basic USB. You can't go wrong. This product is aimed at the hardcore value customer, someone who wants a lot of usable power with a long life battery. They just need a decent inverter, they want to get it at a dirt cheap price, and they don't mind waiting a little bit to charge the base model, and they don't mind moving around 70 pounds. This product is not for somebody who wants the absolute best on the market, nor is it for the portable crowd, as the LEOCH really pushes the boundary of the word portable. If you want all that, you're gonna have to go to JACKERY or BLUETTI and expect to pay more for it. Recommended solar, LEOCH does sell their own 100 watt panels, and they're okay. For the best deal, you're gonna wanna get the LEOCH perk that includes 2 of their 100 watt solar panels for $15.09. Otherwise, you can shop at hobotech.tv/Amazon, click on solar kits, and that'll take you down to the best deals on Rich Solar, BOUGERV, and RENOGY. There you'll find flex panels, rigid panels of stands, suitcase kits, and even the elusive state-of-the-art SIGS panel, which can take a bullet and keep on ticking. Remember that you can easily run up to 2 200 watt solar panels or 3 120 watt solar panels in parallel into the LEOCH before you max out that 20 amp input on the back. And I'm constantly asked every time I do a large solar generator review, can it run an air conditioner? Well, here's your answer. So there it is. It's running this air conditioner, no problem. So if you're interested in the LEOCH, there is a link in the description below that takes you directly to their page where you can buy one of the production models right now. Thanks for watching. If you learned something today, don't forget to give me that thumbs up below, and if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe, and clean my litter box.
Now, if you're curious what I'm using the old prototype LEOCH for that has the burned out solar controller, well, I'm using it as a UPS to power this big IceCo freezer, which I have set to freeze, and then I have a deep freezer here. So these are all packed full of meat and veggies, ready for the apocalypse.
RV Golf Guy, Ant Medic Audio Repair, Andrew, Von Rupp, Richard Cardano,